Now in this topic we are going to learn relation between EMF of cell, terminal voltage of cell and interresistance of a cell. Okay. So the symbol of the cell can be made by this. This is a closed circuit, this is outer circuit, and this is the symbolical representation of a cell. This is interresistance of the cell, this is EMF of the cell. Since it is a closed circuit, then current will flow. Okay, so just give the point. This is A point, this is B point, this is C point, this is D point, and current is flowing from positive terminal to negative terminal. Why positive to negative? Due to Benjamin Franklin. Keep in your mind, in metallic conductor, current never flows from positive terminal to negative, higher to lower. Current always flows from negative terminal to positive terminal, because electrons goes from lower potential to higher potential. But due to Benjamin Franklin, they didn't know about the electrons and protons. That's why it happens. And they said that charge is flowing from positive to negative terminal. Why? Because he was doing an experiment, and during an experiment he found that something has gone from one end to another end. So he concluded that from one point to another point charge is moving, then definitely it is greater here and lesser here. So due to greater amount, it is positive charge and this is negative charge. But now we know that there are electrons which are moving from one point to another. Anyways, so what we want to do, we want to do the relation between EMF, terminal voltage and interresistance. So let's find out. This is a closed circuit. Okay, so anyways you don't need to write here it's a closed circuit or not. It is easily understood. So we want to find out the potential difference between point A and B. So the potential difference point between points A and B is VAB, and it is equal to the potential difference here, this point, because this line and this line is parallel to each other. Since these both lines are parallel to each other, so between points A and B, the potential difference is definitely the potential difference between this line. And what is the potential difference between this line? Let's find out. We will to find out that there is a potential E, and there is a potential between C and D, that is called VCD. So you can write here E minus IR. So what is the potential difference between point C and D? It's IR. Why IR? Because I amount of current is flowing, and small r is the interresistance between the electrodes of a cell, inside the cell, between the electrodes of the cell. So when the current is flowing in the outer circuit, definitely a current is also flowing inside the cell, and that current is I. Okay, so when you multiply I into R, it becomes the potential difference. This is basically a potential drop. And why do you call it a potential drop? Because there is a loss in energy. Why there is a loss in energy? So we try to learn by an image. This is an electron, this is an electrode. This is a bulb, this is a resistance, P point, N point, A point, B point, electrolyte solution. Definitely, electron will move from negative terminal to positive terminal. So electron must be accelerated, must have accelerated due to the potential difference across the electrodes. But when ions move from one electrode to another, left to right or right to left, doesn't matter. So there is a resistance between the electrodes, and due to the resistance, energy will be losing, energy will be lost. And how much energy will be lost? The potential drop which is present here, due to the potential drop which is present here, and this is IR. So the potential difference between positive electrode and negative electrode is EMF of the cell, but due to the resistance between the electrodes, energy will be losing. Okay, so the electrons can't get this amount of potential or acceleration due to this potential. There will be a less of IR due to this resistance. Okay, this is the whole derivation. Actually, it is given in NCERT. So you can follow it. You can write directly in the question paper. If there is a relation comes in the question paper, just make the diagram. You can make this image or that image, and you can say that definitely the electrons would have to be accelerated by the potential difference across the electrons, but due to the resistance between the electrodes, there is a less in kinetic energy, and electron can't get that amount of potential difference acceleration which is across the electrodes, and electrons will be slowing down. We have got a formula. V is equal to E minus IR. Okay, now we have special cases. And what are the special cases? The first case, if current is equal to 0, that means it is an open circuit. If it is an open circuit, V is equal to terminal voltage directly is equal to EM. If current is not equal to 0, that means it is a closed circuit. Then V equal to E minus IR, and terminal voltage will be lesser than EMF. If cell is being charged, then V is equal to E plus IR. You must pay attention to this case, because in the above, just above case, there is a minus, because current is not equal to 0, closed circuit. That means current is taken from the cell. Current is taken from the cell. Current को cell से लिया जाता है. But in this case, if cell is being charged, that means current is given to the cell. Current is given to the cell. And in this case, the terminal voltage is greater than EMF of the cell. When cell is being charged, it means you are charging your phone, so the battery of your phone will have more voltage than its EMF. Or there are cells available in the market which we use in cameras also, which are rechargeable batteries. So if you want to charge a battery, definitely you have to put across its ends more voltage than its potential or EMF. Otherwise, it will start flowing the current and it cannot get charged again. And let's move to the next. If outer resistance is capital R, then what will happen? V is equal to IR. So we can write here IR is equal to E minus IR. IR, take it in the left hand side. I capital R plus small r is equal to E. So you will get a formula for current. I is equal to E upon R plus R. By using these special cases, you can solve some examples. We will solve further. Now further, if outer resistance is 0 or negligible, then what will happen? Current will become maximum, and this is I max is equal to E by R. The same formula here, but in the next case capital R is 0. So if outer resistance is negligible or 0, then maximum current will flow. Now next, again by the same formula, small I capital R plus R is equal to E implies R plus R is equal to E upon I implies capital R is equal to E upon I minus R. So this formula will be used to find out the external resistance or outer resistance. Questions are given in NCERT. Let's move to next. Same formula we are taking again. I r plus small r is equal to E implies E upon I is equal to r plus small r implies small r is equal to E upon I minus r. So you can find out the resistance, you can find out the interresistance by using this formula, and there may have one more formula of interresistance. We know that V equal to E minus IR. So IR is equal to E minus V, implies R is equal to E minus V upon I. Using Ohm's law, E minus V upon I. So I can be written V upon R. Final equation, E minus V into R upon capital V. We can use this formula for interresistance. This formula and that formula. There is a note. For ideal cell, interresistance is 0. In some books, there are two cells which are named cadmium cell and Danish cell. They are named as ideal cell. No cell is ideal. What do you mean by ideal cell? Ideal cell is the cell which has longer EMF. That's all. Not infinite EMF. Next, fresh cell has more internal resistance, but in used cell has less interresistance. Why? Fresh cell, when the cell is newly made, there is an equilibrium inside the cell, charge cannot move, ions cannot move. But when you keep using the cell, the charge on the electrodes decreasing, so as electric force decreasing, chemical force increasing, ions are breaking and they are going onto the electrodes and charging is seen there. I have told you that ideal cells are that cadmium cell and Danish cell, and why they are ideal? Because their EMF is longer but not infinite. So we have done fresh cell has more interresistance but in used, and in NCERT it is given dry cell has more interresistance than other cells. Okay, but it is not explained in NCERT what is a dry cell and that. You may be learning in chemistry. Okay, thank you very much. In the next video, we'll take some question of NCERT exercise.